Okay, and here we are, section 7.1 angles, page 5 of the notes. So we just covered formulas for arc length and area of a sector. And so these are going to go pretty quick here. We are going to start by listing the formula for arc length. Our arc length is S. And we find the arc length by multiplying the radius by the angle theta. So here they tell us the radius is 10 centimeters. I'm going to make sure I have that that measurement in there. Our angle is 2 pi over 7. Remember that radians is unitless, so I don't have to multiply that by the centimeters. So I'm going to multiply this out. We get 20 pi over 7 centimeters. Written that way, it's an exact number. It's a little unsettling. We're not used to using pi. If you would like, though, because it makes a little more sense when we're talking about distances and lengths, to have it in something that we are a little more familiar with, we can multiply the 20 times pi, divide by 7, round to 2 places, we get 8.98 centimeters. So 13 asks for the area of the sector. Area of a sector is 1/2 times theta times r squared. We've got 1/2. Our theta is 2 pi over 7. And we've got 10 centimeters squared. I'm going to stick that unit in there so I remember to square the units as well. We get 100 pi divided by 7 centimeters squared. And once we multiply that out, we get 44.88 centimeters squared. That's rounding to 2 decimal places. You guys, as we go through these, don't hesitate to let me know if you get a different answer, you think I made a mistake somewhere. Always a possibility. So 14, we want to find the central angle of a sector with an arc length of 6.25 and a radius of 4 feet. So again, we're going up to that arc length formula. S equals r times theta. Here they tell us S is 6.25 feet. R is 4 feet. We're trying to solve for theta, so we can divide both sides by 4 feet. And we get theta. You notice that feet over feet cancels. We get 1.5625. I'm going to round to 1.56 radians. Okay. 15. We're going to use some of this information here. It says find the length of the arc. So again, we're looking for arc length. Here's our arc length formula. S equals r times theta. Our r is the 3 feet long. And we've got a 45-degree angle. With all these formulas, we've got to plug these in radians and not degrees. So we need to convert that 45 degrees to radians. We did this one before. We end up with pi over 4 radians. Trying to avoid our picture here. So we get 3 feet times pi over 4 radians. The radians, again, don't really matter. So we get 3 pi over 4 feet, which gives us roughly 2.36 feet. That's the length of the arc. Okay. The rest of this page are the formulas for linear and angular velocity. You'll notice that sometimes it says speed, sometimes it says velocity. Those are fundamentally the same thing. The only difference between speed and velocity, speed is always positive. Velocity could be positive or negative. It indicates direction as well. So we've got a couple of formulas here that we're going to look at. We've got the formula for linear velocity, so straight line velocity. And that's our v equals s over t. V is the linear velocity, so it's kind of the speed that we're traveling along the outside of a circle. S is the arc length, t is the time elapsed. Okay, so whenever we talk about linear velocity, the units are rate, distance over time. So feet over second, feet over minutes, any distance over any measure of time. We've also got a formula for angular velocity. So our angular velocity looks like a fancy little W, that's an omega, and omega equals theta over t, where theta is the central angle that we're moving through over the amount of time that it takes us to sweep through that angle. Okay. Bottom of this page, we can relate angular and linear velocity using the formulas that we have. So here is our relationship between linear velocity and angular velocity. So the linear velocity is the radius times the angular velocity. And we can use any of our three formulas down here as we see fit as we solve the examples coming up.